We're good. So, okay. So we're going to talk about the real number system, and this is review, guys. A lot of this is review from chapter 1, except instead of just talking about rational numbers, guess what we're adding? Irrational numbers. Like, how do they get categorized here? The real number system. Okay. What I want you guys to do is you're going to copy the diagram that I gave you guys here, which is called a Venn diagram. It's with those like bubbles, and I think it's on your book as well. It's going to be a little different because it looks like a giant Easter egg with lots of colors on it. I'm just going to make it a little different. All right. First thing I'm going to do, I'm going to call these the whole time out. They are the natural numbers, which are also known as counting numbers. You guys remember that? You start counting numbers with 1, 2, 3, 4, 5, 6. Yep. After that, we add in the number 0, which gives us the category of not just natural or counting numbers, but what do we call those? Whole numbers. So 0, 1, 2, 3, 4, 5, so on and so forth, right? Those are the whole numbers. When we broaden out from the whole numbers, do you remember what the next category?
No,
Oh, yes, go ahead, Mary.
What number is not a whole number?
What number? Oh, like 1.5? Yeah, those are not whole. And do you guys understand? Whole numbers do not have partial parts or partials. Like, it doesn't have a decimal part or a fractional part. It's just a whole number part. That's it. What was the next category above that? Integers, and we call those Z for Zolin. That's Z, integers. Integers are all the whole numbers and their opposites. So 0, 1, 2, 3, 4, 5, 6, all the way into infinity. And then 0, -1, -2, negative. Those are all the integers, okay? And then after that, we looked at really what chapter 1 was all about. What was that broad category? The rationals, but I call them Q.
I did it like they did in the book.
That's okay, but that's fine. Just make sure you distinguish it. Q, why do we call it Q for rational? Do you remember? Raise your hand. Raise your hand. Why do you call it Q? Sam? Okay, why do you call it Q, Alex?
Because if you already have an R and then you're...
Okay, you already have R. We already use R for range, which we'll talk about later this year. But what's Q stand for again? Like, how does that match up with rational? How does that match up with quotient? And quotients can also be written as fractions. So if you can write a rational number as a fraction, you're talking about a quotient. Okay, then we talked about, really in this chapter, another category. And what's that last category we talked about? Not rationals, but irrational. And I'm going to actually spell that out because I don't want to get confused with letters here. Irrational. I-R-R-A. So here, the rational numbers are not irrational, and irrational numbers are not rational, right? They're separate categories, right? Do you understand that if it's rational, it cannot also be irrational? But all of these numbers fall within the real numbers category. Not fake numbers, imaginary numbers, which is another separate category that we will talk about next year. Infinity is actually a real number. Time out. Infinity can be a real number. I guess I should say that. But it's almost a concept. Like, infinity is a concept because it keeps going. It doesn't really stop as long as we can't figure out that number fully. But, okay, ready? Yes, our last week, Friday, and over the weekend, do you remember the two categories you labeled any number, all those numbers that you're doing your homework? What were the two categories? Yes.
Rational and irrational.
So you said either rational or irrational. Okay. Rational and irrational numbers are all considered real. Okay. You know what real numbers, what that means? Because some of you think like, well, if it's not real, is it fake? Like fake numbers? No. Okay. Here's the definition I want you to write down. Verbal. I'm going to give it to you verbally. Here it goes. Real numbers can be graphed on a number line. That's all you have to put. Real numbers can be graphed on a number line. Real numbers can be graphed on a number line. Wait, there are numbers that cannot be graphed on a number line? That's exactly what I said. Those are called imaginary numbers. We're not talking about those, but there are. Some of you have written an imaginary number by accident and didn't know about it. So we'll go over that next year. And I know that's kind of like, wait, what was it? Well, by accident. And it's okay. Okay, Sam. And see, that's where it's like, yeah, I guess you could say it, but no, imaginary has a certain definition. Cannot be graphed on a number line.
Wouldn't a real number be a number? It could be a decimal number, right?
Mm-hmm. It can be a decimal that.
So a decimal number that ends.
It could be one that ends, one that doesn't end, one that doesn't end and doesn't repeat, one that repeats and ends.
Wait. How do you put a number that doesn't end on a number line?
That is one of the hardest things to come up with. Okay, like the square root. How many of you agree that the square, actually, okay, let's go with this one. The square root of 6. All right, write that one down. Okay, first what I want you to do is tell me which of these categories, so starting with natural all the way to irrational and real numbers, which one of these categories does the square root of 6 fit? All right, here's how I go through the homework. I do this. Is the square root of 6 a natural number? What do you think? No, it's not a natural number. It's not a counting number. Okay, so it's not natural. Is it a whole number? No. Is it an integer? No. Is it irrational? Could you write it as a fraction of integers? No. Is it irrational?
Yes.
Okay, so what I would do is I would say this is irrational and real, right? Because all irrational numbers are also real. Like, that's automatic. Irrational and real.
You have to write real numbers, or can we
You can just write irrational and real. Yeah, or you can say numbers as well. Okay, what is the square root of 6 approximately? So again, getting that. So you're doing this in your head. It's in between these two. It's close to that one. And then this is my decimal approximation. You figure it out. So the square root of 6 is approximately, and you're going to be different from maybe the person next to you, but it's about, don't say it out loud, please just kind of figure it out. So I'm trying to figure it out too. I don't know. Actually, yeah, they don't give it to me either. So I'm going to do my own estimate. I'm going to go with, it's approximately 2.4, 2.3, 2.5 is okay. 2.3, okay, here's what we're going to do now. You have to get, sorry?
You got it exact.
Whoa, nice. What is it? 2.4? 4.4. Okay, so what about it? So listen. I am now requiring you guys to get within 1/10 of the answer. So I would have accepted 2.3, 2.4, 2.5. That's it. Yes, ma'am. Here's square root of 4. Yeah, I know that's kind of tough. Square root of 6. So, okay, we know it's between 2 and 3. You good with that, Maren? Yeah. Okay, is it right in the middle? Why not? Tell me why, because this is going to help you explain why you go 2.4. So what do you think?
Because 2.5 would be.
Well, that's not.
Wait, what? Okay.
How about this? How far is 6 from 4?
2.
How far is 6 from 9?
3.
So you see how it's a little bit further away from 9 than it is from 4, right? So it's not in the middle. It's a little bit closer to 2. So, and then I just take a reasonable estimate. Again, 2.3, 2.4, even 2.5, but I just picked 2.4, which maybe is actually, maybe it's like right here or something. See how that's kind of like a range. I'm not exact. And honestly,
It's like a hurricane.
okay, anyway.
Hurricane 2.4, state of emergency.
Let's go to the next one here. Oh, so Sam, you had a question. How can you graph? How can you put a point on a non-terminating decimal? This is something I'm not talking about specifically, but this is cool. There is a property called the completeness property. This is what it says. Any number that's a real number has one specific spot it goes on in the number line. There's one spot for every real number. Every real number has a spot. So the spot is somewhere in here. Although I don't know exactly. It's 2.44, blah, blah, blah. So it might be a little bit more like right here. Like, how about this? It might be a little bit more right here, but I got it pretty much with a big dot. So it's a little, and then so you're like, wait, Mr. A, isn't it kind of a little bit more off to the right of that? Yep, but there's a point and it's there, but you have to get exact if you could get exact. It just takes a long time. There's a point. All right, I like all these colors. Sorry, can you even see that?
Oh!
There you go. Like this is what I meant to do.
Yeah, we see that.
See, like I picked this,
Just like my ancestors.
and then I said that, and then it's a little more.
It's my word. I see it. I
It's my intestines.
All right, let's look at another number.
Food coloring in it.
Yeah, you must have, there's bad disease, that's your intestines.
Oh my god.
No.
Yeah.
That's hard to see. All right, 0.1011, 0111, 0111, dot, dot, dot. Okay, listen to me carefully. Is it a natural number? Do you naturally count with this? No. Is it a whole number? No, it has a part. Is it an integer? No. Is it a can you write that as a fraction of integers? That's where you have to ask.
No.
Is it terminating? No. But does it repeat in specific, like these digits repeat every time?
Yeah.
So it's also irrational and real. Irrational and real.
They all real.
It's, everyone's going to have to be real unless I threw an imaginary, which I won't do. But you're right, all of them are real.
So you're not gonna put an imaginary.
You get part of it right, because there's other parts. Okay,
You're not gonna put an imaginary number on our quiz.
no.
Okay, good.
Is this a natural number? Do you naturally count negative 1/3, negative 1/3, negative 2/3, negative 3/3? No. Is it a whole number? No, it's a fraction. And it's part of a whole, so it's not just a whole. Is it an integer? Well, it's negative, but is it a negative?
No.
Is it the opposite of a whole number? No. Is it rational? Can it be written as a fraction of integers? Yes. So we say rational and real. Now, was it you, Morris, who said about real? They're all reals? Okay. Do you notice that the three examples I've given are all real numbers? I'm going to say you don't have to put real in all of them because they're all going to be real. So you needed to put rational and irrational. And the last one I think was irrational as well. You don't have to put real because they're all real. Oh.
Yeah.
Let's look at another one. -8/4. This is where I want you to start paying attention a little bit more, guys, because you're going to think one thing and possibly miss a few others. Okay. This number is -8/4. That's how I wrote it. But I need you to think of it in any way it can be written and then decide whether it's natural, whole, whatever. Is this a natural number? You're like, well, no, you don't naturally count. But guys, can I write this in a simplified form? Yes, ma'am? Say it again. Close. -2. Awesome. Thank you, Kate. All right, now is -2, which is the same thing as -8/4, is that a natural number?
Yeah.
Do you naturally count with negatives? No. Is it a whole number? No. Is it an integer?
Yes.
So you write integer, and if it's an integer, it must also be a rational. And if it's a rational, it must have also been a real. But you just leave it there. Yeah, we say rational
Tell me right.
and irrational numbers are mutually exclusive. That means you can't be one and the other. You can't be present here in person, physically in person, and also be present in another place. We're limited. That's mutually exclusive because we are flesh and human, not our Lord. All right. Guys, I need you to tell me what that is. You write on your own, and then we'll go over it. Don't say it out loud, but yes. Yeah, go ahead. This is what you're doing.
So are we writing the like?
Give me which one. For this one, yeah, right. Whatever the categories are, that the square root of 100.
I don't understand what it means. It's like real. Like, I don't know how you can.
Oh, so if it's rational, if you can determine it's rational, it's also real automatically.
So what is irrational?
Okay, if it's irrational, so it's all irrational numbers are non-terminating, non-repeating decimals. So if you see a non-terminating, non-repeating decimal, it's irrational, and that means it has to be also real. So basically, Sam, you know what we did? This lesson is nothing new. It's just telling you that rational and irrational numbers are all real. They're also real.
Oh, so it's not like.
It's not saying like real is a whole nother category. It's just saying, nope, that's just what.
Like, so there's not like some of them that aren't real.
Yes, that we've looked at today, except for imaginary, but don't get concerned too much with that because we're not talking about those. Okay, how many of you say this is a counting number, a natural number?
No, it's not.
Now, now CT was going to say this, and I like this. Ready? He says if you change it to 10, right? Is that what you're going to say? When I changed it to 10, did I really change anything about the value?
No.
So I just rewrote it. It's like, again, Mr. Ray's wearing a different shirt, a bright shirt today. Maybe tomorrow, because he was so embarrassed about the brightness of it, he's going to wear like a really just gray or black shirt.
Yeah.
The fact that I'm wearing a different shirt does not make me a different person. So this is natural and whole. Oh, sorry. And integer. Sorry, it's so sloppy. It's rational, and all rational numbers are also real. It's all of those.
Can we abbreviate and do like the Z for integer and the Q for rational?
I'm okay with that as long as you do the right symbols. So remember, Q is for rational, Z is for integer. All right.
Let's do W and N for natural.
W and N for natural and whole. Okay, next one. 3.2, repeating. This was on your homework, and some of you missed it. I hope you get it right this time. So 3.2, repeating. Repeatings or repeating is, I even sung a song for you guys. All right, is it natural? No. Is it whole? No. Is it an integer? No. Is it a rational number? Yes. Repeating numbers are rational numbers. Repeating decimal numbers are rational numbers.
Can there be numbers that are rational and irrational?
Are rational and what?
And irrational?
No. They're what we say mutually exclusive. You can't be one and the other at the same time. They have to be separate. All right. The square root of 36 over 2. So the square root of 36 over 2. You have to tell me which categories they're in. And I would make it as simple as possible so that I can see all those numbers, because maybe at first I'm like, I don't know. Hold on. Let's finish this up. So what would it be? All right. How many of you know that the square root of 36 is 6? All right. What's 6 over 2?
3.
So the square root of 36 over 2 is 3. That means it's natural, whole, integer, rational. It's all four of those that we talked about. Swivel, I can't believe I'm doing this again.